Good afternoon, everybody. My name is Juan Apolinario C. Reyes. I am the faculty in charge for Biostatistics and Epi, Take two. Take two. Good afternoon, everybody. I am Juan Apolinario C. Reyes, and I am the faculty in charge of this subject, which is Biostatistics. I was told that you were requested to attend a seminar in the Freedom Hall, and you must proceed with that seminar. Okay, so what I shall do to make up for that lost time for my class is to record the lecture that I was supposed to deliver for our first meeting for this subject. Okay, so I will begin now. So again, our delivery of our lectures is going to be online. It's going to be online for the entire semester, and we will use Microsoft Teams. Our LMS is going to be the platform where I will upload the documents. That is also where you will take the exams and the quizzes for this subject. Okay, so let us proceed with the course outline. Okay, so in your LMS you will see here Biostat, Epidemiology. I have difficulty pronouncing that word. Epidemiology. Okay, DDM3A-N. Okay, let's open it. Okay, so you should be seeing this. Okay, course outline, policies, and dates. So this course has two parts. The first part is Biostat, which is concerned with the application of statistics to biological data and medical data. So basically, it's statistics applied to life sciences. Okay, and the second part is going to be about, again, I will try my best. I will say it correctly. The second part is epidemiology. All right. And so epidemiology is like the science of public health. Public health. So normal medicine is concerned with individual diseases, the disease or health of a specific person. But epidemiology is concerned with the health and diseases of a population. Okay? So under biostatistics, again, I have difficulty saying these words. Well, I will reveal to you one reason why I have difficulty speaking and pronouncing the words properly. It's because I'm wearing dentures. By the way, your DDMs, you know what dentures are. I'm wearing a new set of denture, and I just had this a month ago. Okay, so that's one reason why I have difficulty talking. So under Biostat, our goal is to show how we can use the method of stats to process or to do statistical analysis when our data comes from biology or medicine. Okay, and then under, again, I will do my best to say this correctly, under epidemiology. This course aims to study the frequency and pattern of diseases, okay, and health-related issues as far as the public is concerned. Okay, so at the end of this course, students are expected to do the following: describe and make inferences about biological and medical data based on samples, decide on appropriate statistical tests to use and how to undertake them, and describe the various epidemiology that are concerned, or describe the various methods in epidemiology that are concerned with health and diseases of populations. So basically, okay, let us go to, okay, so actually, okay, so this is where the actual course will, or this is how the actual course will begin. So part one, I will talk about stats, okay? The aims of stats, what are the aims of statistics, and then what are the aims of epidemiology, okay? And then after that, I will talk about the part on biostatistics. Okay, so we have descriptive statistics, etc. And then you will see here your first quiz. They already set the date. It's September 9. Then after that, September 16 will be your quiz 2. It's going to be about the various methods to describe and communicate data. That would be the coverage of quiz 2, and the things that are concerned with descriptive statistics. Okay, measures of central tendency, scattering, relative positions, also. Your preliminary exam is set on September 23, and then after that, you will talk about inferential statistics. Inferential statistics, okay, from the word itself, you can tell what it is supposed to do to make inferences, to make educated guesses, okay? And then on October 7, you will have your third quiz. And then after that, we will talk about hypothesis testing, okay? No, under inferential statistics, we will also talk about hypothesis testing, but for continuous data, okay? And then after the third quiz, we will talk about another hypothesis testing, but this one is for categorical data. You will have midterm examination. So the part on epidemiology will begin after the midterm exam. So these are the topics under epidemiology. Final exam is on December 20. These are the references. Biostatistics and epidemiology. You are not required to buy this. You can borrow this from your friends, from your college, because I was told that some of your schoolmates who studied this subject ahead of you had a copy of this book. So maybe you can borrow their book. Another resource is Biostatistics and Epidemiology, a practical guide. I think I have a PDF copy of this book. I will post it. I will share it with you in our LMS. Okay, so this is our grading system. Okay, so I am going to log out. I'm going to log out now. I will remove this window. I will begin my first lecture for biostatistics, basic concepts in statistics. Okay. 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 So, what is the origin of statistics? Well, the word statistics is somewhat related to a word that comes from an entirely different discipline. Okay, statista, and a statista is somewhat like a statesman. Uh, he is a government. Is someone who is employed by the government, but he is occupying the top echelons of the government. So when someone says you are a statesman, you are not an ordinary employee. You are imbued with some serious and some high authority in the government. Okay, and so you might be wondering why or how the word statistics came from that. Okay, the statesman. Well, this was what was happening in Europe in the 18th century. Okay, so Europe in the 18th century is not, its political map is not, it's not even close to the present political map of present day Europe. Europe in during the 18th century are divided into city states. So you can imagine each city is somewhat like uh, a state in itself. Okay, and so there were many city states. So each city states has had their own kings. They had their own independent legislatures, independent armies. Okay, and so you can imagine the things that were happening during these periods. There were frequent rivalry. There were frequent uh, small wars that took place during this period. Of course, you can imagine what were the issues surrounding these battles. It would have to be with conflict in boundaries, in territorial disputes. Okay, so that was usually the concern of those conflicts, territorial disputes, and also, of course, the inheritance, the inheritance of the position of being a king. So there was frequent contests about who is going to succeed the king, so on and so forth. So, as a statesman who is concerned with the affairs of the state, he or she must be concerned with the strength of the army. How does one's army compare with the army of a rival state? And usually, uh, this is how they begin it. They will do a detailed listing, a tabular listing of the resources that they have in the army. Okay, so that tabular listing might appear something like this. Okay, so I'm showing you some pictures. You have tables, columns, headings with the corresponding entries. How many infantries, how many boots, how many rifles do you have? And so this was how statistics began. Okay, and in fact, for the longest time, when people speak about statistics, what they have in mind is a listing. Okay, a listing, something like this. So statistics came to be associated with collection, tabulation, organization, and keeping of data. So this is a list of information, usually numerical data about goods, about services, about prices, or numerical data obtained from observations such as survey, okay, or direct observation. So what are the uses of statistics? Well, in collecting data. You know what? There is a method to the collection of data. It's not like you just go out there. You will just go out there and ask data from people. So it's like there has to be some measure of reliability to the data. That's why you must exercise some care with how you collect data and from who or from what you are obtaining your data. There's a method to it. In other universities where they have a degree program for statistics, they have one subject just for the purposes of guiding students on how to collect data. Usually it's given the title of sampling, okay, the method of getting samples. Well, after you have collected the data, you must process the data and produce information. And that's what we do. That's what we do when we get the average, okay? Okay? So your scores from your quizzes will be an example of a collection of data. And then after processing it, the result will be something like the average. And so having processed the data, what statistics must do next is produce information about the general characteristics of the population. Okay? And so the reason why teachers always compute for your average is because we want to describe your performance in a course. Okay, so that's the purpose of producing that information. And then, of course, after that, okay, we must communicate that information. Okay? After doing the statistical analysis, it produces results. We must communicate that information. And then after that, we shall make inferences. Okay, we shall make inferences. Inferences means educated guesses. Okay, about this thing that we are investigating and about future events and trends. Okay, so what are the sources of data? Well, you don't always have to get those data yourself because our government institutions, the government offices that we know, it's part of their role to collect data and make that data available to the public. Filipinos have the right to obtain information about government transactions and data gathered by government institutions for the purposes of assisting public policy. So if ever time will come, okay, maybe during the time when you may have to do a research, I think students in your course are required to produce a thesis. You might need data. Well, you can get to these government institutions. Okay, so the government institutions, just like what I said, all government offices are required to collect data of some sorts, and they are obligated to share that data to the public. And so the government offices that keep a lot of data would be NEDA. Okay, let me write it. Can I write it here? Yeah, NEDA, National Economic Development Authority. You have the DOH. Okay, this is relevant to you. You have the DOST. You have the DTI. Okay, and of course you have the PSA. I don't know. I'm not sure with the acronym. The Philippine Statistics Board or Philippine Statistics Authority. In fact, they have a website. They have a website. Okay, so you don't have to collect the data yourself. It's possible that the data that you are concerned with are already there, archived in government institutions. There are two general classification of statistics. We have the inferential. Okay, so we have the we have the descriptive statistics and the inferential statistics. So with the descriptive statistics, the word speaks for itself. Our goal is to describe a processed set of data. Okay, that description is often what is being conveyed by this thing called the summary statistics. Okay, and so what information can you find from a summary statistics? The mean, median, mode, variance, standard deviation, frequency distribution, and other things. Of course, after processing those data, okay, you must communicate. You must communicate that information. So this is a task for descriptive statistics. You can communicate that information using tables, graphs, frequency, tabulation, pictographs, so on and so forth. So I have here some examples by which you can communicate your information, although they are not done properly. This one, for example, this bar graph, this is not the right way to do it. Because if your concern is to communicate information, this one does not. It's not doing it. It's not doing, because we don't even know what these are. Look at that. Look at the vertical axis. $10 billion, $9 billion. But what is that? Is that a debt? Is that a national debt? Is that a national income? Okay, so this thing, that is not the right way to do it. Okay, you must give it the proper title and headings. This line graph, so you call this line graph. Okay, you're familiar with graphing. You had been graphing functions ever since you stepped into high school. Okay, so this one is a better communication of statistical data or statistical information. This one is about forecasting the short-term epidemic trajectory. Okay, so if you are careful, you would understand what this means. The goal of this line graph is to tell the public about the trajectory. The trajectory is the direction of the COVID-19 infection. Okay, so the data that is available, to whoever did this study, the data that was available to them are data obtained from March 1, 2022 to April 6. Okay, so you have these points. It's connected by a line, and then these dashed lines. So those are the projections. Okay, those are the projections. Those are the predictions. That is how you can call it. Again, this one is another. This one. Okay, this one is an example of again another way of conveying your information. This one uses the pie chart. And so the other type or category of stat is what we call inferential statistics. Inferential means to make an inference means to make an educated guess. Okay, so inferential statistics. Forgive me, I'm still not used to talking with my dentures. So inferential statistics is concerned with drawing educated guesses about the population based on collected samples. It is concerned with interpreting the results of surveys. It is concerned with performing correlation studies and regression analysis. Okay, so we just came from a national election and going towards the actual national election, you saw that there were many surveys done. Okay, there were many surveys done. The people who administered those surveys came up with educated guesses. Okay, and so their educated guesses aims to answer the following: how many would vote for the senators, for specific senators? So they can make those kind of projections based on the result of the survey. Okay, and then who will make it to the top 12? Okay, what are their ranks? Now in correlation studies, this thing would be an example of issues that might appear in correlation studies. Is the sex of a voter correlated with the vote of that person? Is the sex of a person correlated with his or her choice of occupation? Is the socioeconomic class of a person, does it affect his or her choice of brands of particular commercial goods, so on and so forth? Okay, so those will be an example of correlation studies. Now, regression analysis, I have a separate slide for that. Yeah, okay. So in correlation studies, in regression analysis, what you do is you collect bivariate data. So a bivariate data, these are like a set of data that has two components. Okay, you can look at this as each data has two components, x and y. As some statisticians would call x to be the independent variable, y is the dependent variable. Sometimes they call it the predictor. X is the predictor variable, something like that, and y is the predicted variable. So you can look at this as the coordinates of a point. Okay, so one example of a bivariate data would be something like your IQ. Okay, your IQ, and IQ can be measured. Okay, and your score. Let's say, for example, your score in the entrance exam when you entered LPU. Okay, and so there are many students who passed the entrance exam. So we can collect their IQs and corresponding scores, and so we will come up with a collection of pairs of data values. So you can look at this as the coordinates of a point in your rectangular coordinate system. We will plot them, and this is what can happen. Okay, you call these things the scatter plots. Okay, we will plot them. Okay, in your rectangular coordinate system, and our goal is to produce an equation that estimates the relationship between IQ and the score of students in the entrance examination. You may have seen this. Okay? You may have seen this, or maybe some of you were my students in math in the modern world, and I show how this is done. So this one falls under inferential statistics, under regression analysis. Now, again, what educated guesses can you make given that we have this information? The educated guess that you can make from this information is we can make educated guesses about the score of a student in an entrance examination based on his or her IQ. Okay, so that's the point. That's the point. So I will go now to some fundamental terms and terminologies that appear in statistics. Population versus sample. You can look at population as universal set. Okay, so you have that term in math, universal set. The sample is something that you can look at as a subset. Okay, the population is everything or everybody. The sample is a subset. But instead, that sample must be a representative subset of the population. It must be representative. Well, you can look at the sample as the reduced size. Okay, diba? You can magnify, and you can, what's the opposite of magnification? You can reduce. It is reduced. Okay, the sample is the reduced version of the bigger population. Okay. So basically it's the same. It's the same, except that a sample is a smaller version of the population. There is a method to obtain the sample. And just like what I told you, in other universities where where a degree program in Bachelor of Science in Statistics is given, they have a subject, one subject for one semester devoted entirely for getting a sample or getting data. Okay, how do you do? How do you obtain the sample? You do it through random sampling. Okay, so when you say a random sampling or random sample, everything or everyone in the population has an equal chance of being included in the sample. How do you achieve that? Well, you can do a simple random sampling, systematic sampling, or stratified random sampling. We do this often. We do this often. Okay, wait a minute. Okay, I have these two pictures here. Okay, because I want to show to you that getting a sample is not easy as scooping, getting a bucket of water from the lake. That does not make for a sample. Okay, so let's say for example, you are somebody from the Department of Environmental, DENR, Department of Environment and Natural Resources. So one of the roles of that office is to know what what are the existing populations of living things in a lake. That's part of their job. They ought to know. They ought to know, okay, Taal Lake. Ano bang mga vertebrate animals na nasa Taal Lake? Pag sinabing vertebrate animals, yung mga spinal column, spinal cord. So, hindi lang isda. Bayawa, ahas, those are vertebrate animals. Okay, so how do you do that? How do you know? How do you establish kung ano ang populations ng mga vertebrate animals in a lake such as Taal Lake? Well, this is what you can do. You can get a sample. A net will do. A net, a fishing line, a net. Okay, here in this area, so this area is close to the coastal area. They call this littoral. Littoral. This part is what you call the littoral area or littoral. Yeah, it's a body of water that is close to the banks, to the coastal lands. So you will get a sample from that place. You will also get a sample from the middle of the lake. You will get samples in this part. This is halfway between the surface and the bottom, and then you will also get samples from the bottom dwellers of this lake. So that is how you get it. Okay, that is how you administer a systematic and stratified random sampling. Now we have here a river. Okay, and so this river has three segments. That's how you can call it. You have the upper part of the river, the middle part, and then the lower part. So you don't. When you are getting a sample, you don't just go to one spot because there are organisms that inhabit a different spot in the river. Okay, they could be organisms that can be found only here at the upper river. There are organisms that can be found only in the middle, so on and so forth. I'm telling you, there's a method to this, and it's not easy to. It's not easy. It's not easy to get samples, which is why sometimes there are organizations who discovered that they can make business from this because it's not easy to do, even though the information from these things are very important. And that's why, for example, the people who undertook the surveys before the national elections, they are businesses. They are get paid. And probably they are being paid an ample amount of money. So I know of some people who established consulting firm for the DNR, and what they do is they do the dirty work. I would call it dirty work for DNR. Okay, because it's complicated. Sometimes it requires years to get a sample. Now you might be wondering why can getting the sample take years? For example, we are concerned with classification of vertebrate animals in the lake or the classifications of microscopic organisms in the river. Why? Because there are organisms that appear seasonally. Okay, there are organisms that appear seasonally. They appear during rainy seasons. Some appear during summer seasons, and there are also organisms that appear depending on the presence of light. So during daytime, they will go out, explore their environment, and then during nighttime they will retreat. And then again, there are microorganisms that appear during nighttime. So if you want to produce a truly representative sample, you must pay attention to all those things. What am I doing? I am enumerating some fundamental concepts that appear in statistics. Okay? For example, this one, statistic versus parameter. So a statistic is a number that describes a characteristic of a sample. A parameter is a number that describes a characteristic of a population. So most of the time, the numbers that we shall see would be the statistic. These are the numbers that describe a characteristic of a sample. And so we have two sets of symbols for statistic and parameter. Okay, this is our symbol for the mean when we are talking about the mean of a sample. Mu. Okay, this is mu. Okay, you can call this simply as the average, mean or average. But when you are talking about the average that is obtained from the population, you population mean, or sometimes they call it mu. Okay, standard deviation. This is sigma also. The the big letter for sigma is something like this. That is also sigma. So this one is something like a small case. Variance, proportion, so on and so forth. So in most cases, it is not practical and possibly very expensive to get the population parameters, because it's like getting data from the entire universal set. It's like getting data from the entire population, and that is rarely done. Okay, we always obtain data from sample, and so these are the pertinent issues that appear when we compare a statistic to the parameter. What should be the sample size? Okay, so if we are concerned with survey, how many respondents must participate in the survey so that, yeah, okay, you can look at this as an error. Okay, and usually it's the statistician who will declare the error. So you want to produce a very small error, and the absolute difference between the true population mean and the sample mean must be less than that error. And so the pertinent question for that is, how big must the sample be so that we can minimize the error? We can minimize the difference between the true parameter and the sample statistic. Okay, so we have these two categories of variables. We have quantitative variable, we have qualitative variables. In quantitative, these are numeric variables. They represent a measurable quality, such as your height, your weight, number of offspring, annual income, sales, economic growth, etc. For qualitative are categorical variables. This is like a classification of data, okay, of a classification of an information. So when you say classification, just think about a name. It's like your purpose your purpose or your aim whenever you meet whenever you're presented a qualitative variable is to give it a name. What is it? Okay, what is it? Where do you put it? Or under what classification would you put it? So these are examples of qualitative variables: the sex, eye color, brand names, classification of fishes, level of education, marital status, so on and so forth. You may have seen this. Okay, these are the levels of measurement. So the most rudimentary level of measurement would be nominal. Your purpose is to just give it a name. Where does it belong? In what classification does it belong? Okay? That's why you begin with nominal. So one example of that would be eye color. And then the next level of measurement is a set of data that can be ranked. So you gave it the word for that is ordinal. It can be ranked. It has a natural order. So level of satisfaction. So an ordinal measurement has the quality of a nominal measurement, but there is something added to it. It has an order. So the levels of satisfaction would be an example of an ordinal variable or ordinal data. Okay, interval measurement. Okay, an example would be temperature. Okay, in almost all literature that discusses or introduces interval measurement, they always follow it up with this word temperature to illustrate to you the meaning of a variable that has whose level of measurement is interval. Okay, it says here it has no true zero value. When you say zero, it's nothing, nada. But when you say 0 degrees Celsius, it is not equivalent to saying that there is no temperature. There is a temperature. It's freezing, and so that is the reason why they always follow-up interval with this example temperature. Ratio is another level of measurement wherein it has a natural order. There is a quantifiable difference between values, but it has no true zero value. No, no, no. I'm sorry. I'm wrong. It has a true zero value. Okay? It has a true zero value. So when you say the profit is zero, it really means that it has no profit. When you say the 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 volume is zero, it has no volume. Okay. So this one ratio has a natural order quantifiable difference between values, but it has a true zero value. That is how it should be put. I'm sorry for that. Okay, so that is all for now. Okay. I will continue next meeting.